Good evening, grade 5. This is Mr. B, and yeah, we're here to bring another lesson. Today we're dealing with area. Lots of fun. So we've been dealing with perimeter and lengths, and we've been reviewing some of the things we learned earlier in the year. And today we are looking into doing some area. So, what is that all about? Well, let's start by just making a rectangle. So we've been kind of dealing with perimeter and making little rectangles out of squares the past few days. So I guess we'll do one with 4 squares and one with 3 squares. So that's a lovely square shape, and we're doing one with 3 here. Okay. So those are our 2 shapes. And which one? Now we have to understand that each of these squares we're thinking of is about the same size, with one of these sides being 1 centimeter. So even though I didn't do a perfect job drawing this, think of each square being the same size. So which one would be bigger? Well, if you have 3 squares versus 4 squares, the 4 squares one's actually going to be bigger, even if I didn't draw them as well as I could have. So right, because right, each one of these squares is 1 by 1 by 1, so we're kind of considering them the same size. So if you have more of the same size of something, you're going to be bigger than that, than less. So yeah, and so this is kind of an idea that we're going to be dealing with more today about squares as a unit of area. So if we draw some shapes out of squares, we could count how big they are, and we're considering that all the squares, even though I might not draw them perfectly, they are all the same size in our heads here. So yeah, if we were to just consider this, if we were just talking about squares of area, how many squares of area do we have? Well, we have 1 square, 2 squares, 3 squares, 4 squares, 5 squares, 6 squares. So we have 6, you could say 6 square units, right? We could say that for now. 6 square units. This one over here was 4, let's just say squares. Oh, terrible A. And this one here was 3 squares. That works easier. So yeah, and you could say, yeah, 6 squares is going to be bigger than 3 squares, as long as you're saying the squares are about the same size. So if we were in a classroom setting, I'd probably just have actual squares out instead of having to draw them to get them all equal. But yeah, here you go. So this is kind of what we're dealing with. And so yeah, 4 squares is bigger than 3 squares, and 6 squares is bigger than 4 squares, even if they're shaped differently. If the squares are the same size, right? If you have 1 square, right, that's one size, and then you take that square and you go like this, 1 square is smaller than 2 squares together, right? So that's the main idea here. So when we're determining an area of a shape on grids, so let's actually make this a nice grid so I can work a bit better. So let's get our draw. Okay, so here we go. So if we have a grid and I draw a little rectangle here, we'll just say we'll draw a rectangle like this, and we wanted to just see how big it was with just saying squares, and I did something like this, and you found a square that was sort of broken up here. The way we can find out the area is quite simple. In this case, yeah, this is a fairly simple thing. We just have to, chop it up like this, and then we can say, well, this is 6 squares big, right? So that's 6 squares. And if I did one that was just like this, we could do the same thing, right? And now with the nice lines to help us, we can kind of get the idea, right? This one is bigger than this one, which is only 4 squares. And then if we have one that is just 2 squares, right, that's smaller than the other ones. So if you have 6 squares, it's going to be bigger than 4 squares, and 2 squares is going to be smaller than both of them. So yeah, that's just the basic idea, and so we're going to get into the bigger thing here now. So I think before you guys did learn about this idea of square centimeters. So square centimeters are a unit that we can measure like this, or we write down at least, well, here, first, before we get there, let's just say that a square, this is 1 centimeter, okay, and a square centimeter is going to be a box made out of different sides of 1 centimeter each. So each of these will be 1 centimeter, and this will be 1 centimeter as well, and that is considered a square centimeter. And the way we can also write that is a centimeter squared. So this is the symbol for square centimeters. So you have a centimeter, and then you have it to the power of 2, which is kind of like centimeter times centimeter. We'll get into exponents later, but this is the symbol for square centimeters. So you get that a square centimeter is like a box made out of, with each side being 1 centimeter, and they're all equal. So it's a right angle shape, and so each side and each angle will be the same, and it'll always, 1 square centimeter will always be 1 square centimeters. And if you have 2, say we had this would be kind of like 2 centimeters squared, right? If we were saying that this is each side here is 1 centimeter, right? Now remember, the perimeter could be different, but this is 2 square centimeters because they're both, it's two boxes made up out of 1 centimeter sides. So that is quite helpful. Now if I have a rectangle here, and I make it 3 squares long, and then 2 squares thick, how many square centimeters would we have here? Well, we would have 6 squared centimeters, and we just write that like that. Remember, with the 2 there, and yeah, there's 6 boxes. We're saying that each side here is 1 centimeter each, so so each of these boxes is a little box of 1 centimeters, and we have 6 of those boxes put together, and that gives us 6 squared centimeters. So that's the basic idea. Now the length here is, right, the length here is 3 centimeters, and the width is 2 centimeters. And so you see how there's difference, right? So centimeters is how we measure length. So centimeters or meters or anything without a 2 is how we measure length. Centimeters squared equals area. And later we'll maybe learn about centimeters cubed, which is volume, but we won't get into that yet. But yeah, centimeters squared is area. So centimeters normally is length, or meters or anything without the 2 beside it is for a length. And that's why it's 2 centimeters like this way, because right, each of these sides is 1 centimeter, and then this is 3, and that equals 6. Now something that we're going to learn tomorrow, but I thought, this is a good place to learn it, is that area, the way we find area without looking at it in a rectangle, just a simple rectangle like this, is you times the length. So the length times width, and that equals area. And you can see this, right? So if you do 2 centimeters, I guess, times 3 centimeters, that equals 6 centimeters squared. And the reason why it's squared is because you're timing centimeters by centimeters. So those centimeters kind of join together and make like a centimeters to the power of 2. And so it makes centimeters squared. So yeah, 2 times 3, so 2 centimeters times 3 centimeters equals 6 centimeters squared. So when you times the length by the width, you'll get the area. And the area will always be in centimeters squared, and the lengths, the different lengths, and width is really just another way of saying length, is always going to be in just regular old centimeters. So, reviewing different units. So, what are we saying here? Well, we know that a length can be measured in things like centimeters or meters or kilometers or millimeters, right? We can have millimeters. Let's just say millimeters. Oh, that's bad looking M. So millimeters, and then you can even have nanometers, and it goes all the way down. But there's lots of different measurements, right, in length. Well, the same is true for area. So these are all for length. So that's all for length, but area also has similar ones. So how many before? What is the amount of centimeters that go into a meter? Well, you need 100 centimeters equals a meter, and you need 1,000 meters to equal 1 kilometer. Well, we know that there are such things as centimeters squared. Well, what do you think 100 centimeters squared is going to equal? Well, it's going to equal 1 meter squared. Just like 100 centimeters equals 1 meter, 100 centimeters squared equals 1 meter squared. And the same thing is true if you have 1,000 meters squared, that equals 1 kilometer squared. So this is fairly straightforward. Basically the same thing that applies to centimeters and meters and kilometers applies to centimeters squared, meters squared, and kilometers squared. So just the fact is that there are different sizes. And basically, when I say 1 meter squared, right, what are we talking about? Well, when we say 1 centimeter squared, we're talking about a box like this with 1 centimeter here, 1 centimeter here, 1 centimeter here, and 1 centimeter here. When we have 1 meter squared, that's going to equal a box that is 1 meter in size on each of these, right? So it's going to look like this. It's going to be a bigger box, right? So obviously I can't display a meter big, but you guys kind of know a meter stick. Imagine creating a box out of meter sticks. It's going to be a lot bigger than if you create a box out of centimeters. And that's basically the case, because inside of a box of meters, you could fit 100 boxes of centimeters. And then even bigger than that, imagine a 1 kilometer squared is going to be way bigger, right? That's a humongous box, because that means that you have a ginormous box, and I can't show it here, but which with each side being 1 kilometer, and 1 kilometer. So in Europe a lot, and sometimes in Canada's weird with how we measure things. They often measure things in square kilometers for land, and it makes sense. Basically, you just say, okay, the land is this many squared kilometers. We use acres or hectares, often acres. So yeah, I don't even know how many acres are in a squared kilometer, but I know what a squared kilometer is just by understanding here that a squared kilometer is just a box made up of 1 kilometer each way. So if you were to walk 1 kilometer one way, then turn 90 degrees, walk another kilometer, turn 90 degrees and walk another kilometer, and then turn 90 degrees again and walk 1 other kilometer, you would arrive back at the same place, and you would have walked a square kilometer, right? Because you're basically making a square out of kilometers. And that's the idea. And here you're making a square out of meters. And there you're making a square out of centimeters. So yeah, and now we're just getting into choosing the appropriate units. So if I was trying to ask you to tell me the size of a screen, and I have a BlackBerry, which may be kind of silly, but I got a BlackBerry, so it's got all these buttons and stuff, and okay, too much work to get all the buttons in there. It's got buttons, but it also has the touch screen here. And I was to ask how many, how big this screen is, what the area of the screen is. What would you measure it in? Would you measure it in kilometers squared? Would that make sense? Well, probably not, right? Because a kilometer is huge. A kilometer is really big, right? It's not a small distance. 1 kilometer is quite big, and my little phone is nowhere even near a kilometer. So a kilometer squared is a giant box of kilometers. So it's definitely not going to be a kilometer squared. Well, would it be maybe a meter squared that we'd measured in square meters? Well, just think again. Remember if we had those rulers in class, the big long rulers that we use for sword fighting, and we were to push all of them alongside of each other, do you think my phone would be even 1 square meter? Very unlikely. Remember that some of you guys are almost the size of a meter. You're a bit taller than a meter, right? We got you guys are like a little bit taller than a meter. That is the best drawn person ever. so yeah, so some of you guys are a bit taller than a meter, and my little phone is only like that big, so it's not going to be that either. So we're probably going to measure it in squared centimeters, right? Because you could fit a lot of squared centimeters there, so it'd probably be centimeters squared. It could even be, if you wanted to be more like precise, you could probably use millimeters squared, right? Because that's just the little boxes made out of little millimeters, and yeah, they're really small, right? So if you wanted to be very accurate, you could say, okay, it's so many millimeters squared. Now, instead, say we were measuring the size of the gym. So the gym's pretty big, right? Would we want to measure, I mean, it's not the biggest, but let's just think of our little gym that we had there. Would we want to measure that in millimeters squared, where the millimeter is like that big? Maybe it's probably even smaller than that in the gym, right? Remember how big a millimeter is on the ruler? It's like tiny, weeny. So how many? It would be like tons and tons of millimeters squared. So we probably don't want to do that. We probably would rather measure it in meters squared, because you could probably put a lot of meter stick squares in there. I can't measure it because I'm not there at the school, but yeah, you probably want to measure this with meters squared. So just like when we're doing other length and perimeter, you want to know what unit you should use. You shouldn't be using a silly unit like nanometers to measure the size of the moon, or millimeters to measure the size of the moon, because you're going to get like so many millimeters. And imagine if you try and measure that with little millimeters, and you have this little tiny millimeter square unit, and you're just going around. That'll take you forever. Obviously, technology you can convert it to a millimeter squared, but you're going to get this massive number. And really, no one wants to deal with massive numbers. So you rather find the unit that's good. For the moon, you probably want to use kilometers squared. That's probably what you want to use. For my phone, millimeters squared, maybe centimeters squared. And for like maybe like a little ant, definitely millimeters squared. For the little tiny chip inside your phone, maybe millimeters squared or even nanometers squared, especially if you're trying to talk about the wires. And yeah, so on and so forth. You want to use the right unit. So guys, that's our lesson. I hope that everyone got that. You're just working on 2 pages for today. And remember that question 6 we're going to not do, because it kind of asks you to measure things in the classroom. And sadly, we're not there. So no soccer and no measuring things in the classroom. So that's it, guys. If you want, maybe you can try and measure things around your house and substitute them and you could cross them out and do it, but that's up to you. Otherwise, yeah, just have a good day and hope everyone's enjoying the nice weather. Okay, guys, this is Mr. B. Bye-bye.